Okay, so you've run through these a couple times. What's one process question that you still have? What's one thing you want to ask about? Try to be as specific as you can, yeah.
Like the crossing. What's that for? What do you mean?
What's the crossing of asymptotes for? Good question. I like that. Okay. Like why?
Horizontal, right?
Why do we care? Or oblique, yes. You can think about this. Horizontal are oblique asymptotes. I mean, well, excuse me, no, they're not.
Because like I thought
You can't cross vertical. You can cross HA and OA.
Okay.
We'll get to why is important. That's a good question. Anything else? What other things you want to know about? Anything about the process itself that you're unsure of that you want to ask about? Yeah, 1 and then 2, yeah?
What do you do when you have two binomials and one that not?
What do you mean? After you factor?
Well, yeah. When all the examples have been divided by x minus 1 and there's only one.
Oh.
There are two.
Oh, in terms of PLD. Ah, that's a good question. We have not. That's good job. We have not done that. That's great. I like that. And that's going to sound weird on the audio. Yes.
Could you explain in your video
Yep.
last night? There's a thing where you were able to divide.
Yeah.
Like
What at the end? The second thing I did.
Yeah.
What did I do there? Do you remember what I tried to link?
The synthetic division.
Yeah. So what's the link between? Good. Someone's paying attention. I like that. PLD and synthetic division. That's a great question. What's the link? Yeah. Any other questions? Okay, so the short answers, and then we'll do some examples. What's the crossing of asymptotes for? It's the simplest way I can put it is this. Asymptotes are very hard to cross, so when you work with them, crossing points are very useful because they tell you all about, well, because I'm being really convoluted in this explanation, because they give you an anchor point, would be a good way to say it. So generally you have to stay way away from asymptotes. You know, you get closer, but you can never cross. But is it a rare occurrence that they cross? Generally speaking, and is it very helpful in terms of the overall shape of the graph? Absolutely. We're going to do an example, and you'll see why. What do you do when you have two binomials in the denominator in terms of polynomial long division? Nothing changes. The system stays the same. You just have to multiply larger polynomials. We can do one of those too. It's not something we generally have to do because you're right. I've been staying with dividing by a single binomial. Like what happens if you wanted to divide a 4th degree by a quadratic? You know, something a little bigger. What's the link between polynomial long division and synthetic division? The short answer to this is when the divisor is a binomial, a single. If you know what you are doing, you can use synthetic division instead. Yes, it's much faster, but you got to be careful. Basically, it's like shorthand. It's like those court reporters; they can record everything,
Yeah.
but you need to be real careful. Okay, so let's do an example. I came up with a good one over here. Let's use, yeah, R5. That's the one we wanted to do. Okay, so let's talk about R5. Copy. That's pretty cool. Did you see what it gave me there? It was pretty neat. Okay, here we go. So let us try to get a nice picture of R5. Now, you guys worked on this one last night, right? So you should know a little bit about it at least. This one's a little bit harder than the other ones, mainly because we're dealing with higher order polynomials than quadratics, right? Right? Something like that? Yeah, I think so. So, can somebody? I got to go back to randomization. That was a good thing for us to do. Who can tell me? Oh, let's see. Ethan Goss, can you factor the numerator for me? Tell me what it is. So while he's looking, everybody else make sure they're prepared to answer these questions. Okay, phone a friend here. Corey, can you tell me? Numerator. Anybody. Numerator. Shock.
X minus 2.
X minus 2, yeah? And?
That's pretty fun today, isn't it?
X plus 1, yeah. He's like, I've got to get into the game here. This ain't practice, this is a game. Do people agree with that? Doesn't matter what order they're in. In your world, does the order of multiplication matter? In other worlds, does it? Yeah, it does. You'll look. We might actually look at that later. Not today, but later in the class. Denominator time. Let's go with Jessica Brown. What do you got?
For the denominator?
Yes.
Oh, I see.
Stalling.
No, I have the whole
yeah.
thing
What is
right
it?
now. I can't see on my paper. That
We're going to
one.
move on
Yeah, I
to...
guess
Lawler is your friend, yeah.
X minus 1.
Okay, X minus 1. Do you have another one, Brown?
so.
Okay, Lawler, go.
Waller.
X plus 5 and?
X plus 3.
X plus 3. So we factored it. Now we can do some interesting things. Actually, before we even factored it, what's really key? What can we figure out about this even before we factor? What's the easy thing we can do right now? Horizontal. Why? Okay, can we get a complete sentence like, cause it's cool? The degree of the numerator are the same. So the degree of the numerator and denominators are they're the same. Got it? So what do we now know? We know there's a horizontal asymptote. What is the horizontal asymptote? It's 1. You now look at the leading coefficients. So it's y equals 1. You need to say y equals 1. This also tells us, is there an OA? No. There is not. Now we factored. I like farming out to factoring to you guys. I get really nervous when I multiply them out, and because when I don't make things factorable, do you guys get angry?
Yeah.
It was totally unintentional. I forgot how angry you guys get. So angry, so angry. Why doesn't it work? I want it to work. I want it to work. So what's the domain here? Let's go with Grace. What's the domain? Yeah.
It's not equal 1, minus 5, and minus 3.
How? Intercepts. Who can list for me the intercepts? Go.
2, 0,
Yep.
1, 0,
Yep.
0, 2,
And 0, 2 over 5? Exactly. Who agrees with those? Why are there... So there's one y-intercept, which is a good thing. How many x-intercepts are there? 2 x-intercepts. What about negative 3? It can't be. The domain... It cancels?
So wouldn't that be where the vertical
No, because it cancels, what does it become? What does it become? Yeah, let's not put the... Okay, no. Let's not... Vertical asymptote removal discontinuity. I think I just heard someone say removable asymptote, which is going to present problems. The terminology, there's enough of it already. In future math classes, I'll tell you, it will get comically weird. There's a field of math. You can look it up. If you. This is a great thing to look into, topology. It's the study of surfaces, but very rarely can you actually see the surfaces. Topology is a class where a coffee cup and a donut are the same shape. Why is a coffee cup and a donut the same shape? Why are they the same shape? Yeah. That's a good guess. If you could infinitely if you had an infinitely malleable coffee cup that you could bend, but you cannot cut or puncture, what could you pull it into? A donut. You could pull it into a donut because in a coffee cup without a top like this, how many holes are there? There's 1. How many holes in a donut are there? 1. Topology is a great thing to look into. What I find really hard about topology, 1, crazy hard, but 2, the terminology was crazy redundant. You'd have normal spaces, perfect normal spaces, like perfect super normal spaces. You'd have like all these things that meant the same thing. Look it up. It's a fun thing to look into. If you want to take more math, it's a great thing. When I finally started understanding it the second time I took it, that's how it works. So, what about symmetry? Let's see here. Who are we going to call on for symmetry? Autumn. Neither. Yeah. Are you tending to see a lot of neither on these? Yeah. So is it just a really nice thing if it is even or odd? Yeah. It's possible. It's certainly possible. So what's next here? Oh, VA, vertical asymptotes. Eliza, can you tell me what the two vertical asymptotes are?
X equals 1 and X equals
Bingo! I like that. You said the X equals. That's very nice. Now, we already did, oh, VARD. Let's pair these up properly. The removal of discontinuity occurs where? No. It's -3, comma.
Negative 5 over 1.
Yeah, do you agree with that? Once you simplify, you have to plug it back in. Okay, that's a good analysis so far. Good job. And now we have we actually already did this, HACOA. What do we now know? We already know it's y equals 1, and there is none. So what's the last thing we need to do? Cross. And it's trying to cross how many of these asymptotes are we looking at? Just one of them, the horizontal at y equals 1. If we want to find where two things intersect, what do you have to do? No, not plug them in. Set them equal. The graph of something is the picture, the graphical representation of all the solutions to that system. If you have two systems and you want to know where they're both true, you're looking at where they intersect. If this is all the solution sets to one thing, and this is all the solution sets to another, where they cross is the solution set to both of them. Exactly. So, what do we have here? What's our original equation? We take our original one. It's much easier to deal with in the unfactored form. And we set it equal to 1. That's it. You set it. That's the equation, right? So what do you do to both sides? Yeah, multiply by the denominator. So you're just taking this and going whoop, like that. What cancels from both sides? And now let's put everything on the same side. How many x squareds do we have? 5 of them. How many x's do we have? 12 of them. And how many constants do we have? Minus what? And then you look at this. This is a quadratic, right? Huh? Can you solve quadratics? You hope it's factoring. Nicely factorable. Thank you. Is it nicely factorable? Oh, yeah, it is. It is nicely factorable. So what does that tell you the solutions are? 3/5 and -3. So, but you ding, 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 ding. What value right there kind of sets off a warning bell? Yeah, -3. But what is this? It can't be. What did we do? We can't cross there. Why not? It's an RD. It's a removable discontinuity. Can it cross at a removable discontinuity? No, the function doesn't exist at a removable discontinuity. We just generated a false answer. You need to always check reality. In this case, reality is your domain. Is this all the information that I've told you to gather?
Yes.
So let's put it together and see what kind of picture we get. Am I looking for a super accurate graph? No. Generalized shapes here. Do you even have the capability of getting curvature in precalculus? Not really. You guys know how to find like the highest points when they're quadratics. Do you know how to find highest points by hand of anything else? No, you don't. So you're estimating here. So what were our zeros? Can you remind me what they were? We're at -3 and 1, right? Is that correct? What were the...
-5.
No. That's the hole in the domain. It's 2 and -1. Thank you. 2 and -1. Right, those are the intercepts. And then what's the one? 2/5, I think. Right? Is that correct?
Yes.
And then we have a vertical asymptote where? There are 2 of them. We have at 1 and -5. Is the scale super important? Not in this case. We're doing general sketches right now. There's one other asymptote. What is it? What's the other asymptote? Y equals 1. Thank you. It's y equals 1. So let's take the green here and just go doo, 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 doo. So what's the equation of that? It's y equals 1, and this is x equals 1, and this is x equals... We crossed that that green barrier, right? Where did we cross it? Do you remember? -3/5, right? What's the coordinate? Well, it crosses, it's 3/5, and what's the line it's crossing? Y equals 1. Y equals 1. That's the intersection it's crossing. We're good? So where's that point? Well, this is 1. Where's 3/5? It's right about there. There's one other point we haven't put on there. What's the one point we haven't put on there that we do know? Give you a hint. Yeah, the removable discontinuity. Where is it? We figured it out. This is really hard to do. Yeah, it's right here, right? -3, -5/4. So where's that? I don't know, right about here. So do we have some dots? Can we connect them now? Yeah, we can. Ready? So let's connect the dots. We know this has to go like this. Why can't it go down again? Well, it can't cross the asymptote, but why can't it just go ooh, like that? Cross the x-axis. There are no others. Has to go up. So where does this one have to go now? Travels this way, right? Wonderful. Oh, that's nice. So what do we do next? Well, we know it crosses 2 here, so what is that going to have to do? Use your hands. What's it going to look like? Wah, exactly. It's going to look like this. Is that cool? There's one piece that's left. What's missing? The domain of this function is everything except -5. Okay, that's check. That's good. Everything except there's -3, and this is, what was that, 3/5 right there? Yeah. What's missing? We haven't graphed a part of this graph. What part haven't we graphed yet? Everything to the left of? Yeah, we don't know what's over here. So how do we figure out what goes over there? Yes, exactly. 2 things. Can we cross this green line anywhere else? No. Can we cross the axis anywhere else? Your asymptotes have really high gravity, so we're either, you know, it's going to look like this or it's going to look like that. Can it point down? There's many reasons why it cannot point down. What's one reason it can't point down? Exactly. If it was pointing down, where'd the other end have to go? It would have to cross. Can it do that? No. And doubly, though, this is what I want you to look at primarily. This is x equals -5. What factor does that come out of? It comes out of that factor. What's the power of that factor? 1. It is said that the multiplicity equals 1, which is odd. And because it's odd, you know it goes up and down or down and up. Well, we know it definitely goes down right there. So what does it have to do on the other side? It definitely has to go up. There it is. So this is the graph right there with the important points labeled. Is that pretty cool or what? So how could we potentially check our answer? Put it to the calculator and graph it? Absolutely. You could potentially put this in your calculator. I don't know if I did yet. No, I didn't put it in. It's fine. We don't have to do it on this one. Okay, so how do you feel about this right now? How do you feel about this? Decent? Yeah. Here's the thing. Like polynomial long division, what's the really dangerous thing about polynomial long division? What's the easiest mistake? Ah, negatives. Easy to mess up. What's the tricky thing about synthetic division? Easy to mess up. In terms of making these graphs, what happens if we messed up one of the factorizations and we put our intercept like here? Does that mess up our logic for everything else pretty much? Yeah. So here's a tip I just want to say. If something seems odd, check it. Mainly because you don't want to go too far on bad information. Does that make sense? Okay, so I want to introduce a new segment. You can think of it as a TV show, and I'm going to introduce different segments to you. Here we go. So we're going to look at a new segment called Web Tools of the Day. So there's a few things I want to show you. Help you with this class and other classes. I'm going to try to give you as many as I can come up with. Has anybody seen this site before? It's pretty new. It's called Quickie. What it does is it's essentially a port to Wikipedia, but it's a little bit smarter than Wikipedia, and it's not meant for the same type of analysis. Give me something that you want to know about. A place, favorite actor, hometown, something. Person, place, or thing you want to know something about. Anything. Pick it. First thing that comes to mind. What? Granby? Let's try it. Granby, Vermont. Let's see what it does. It pulls.
The population was 86 at the 2000 census. Metro the most populated incorporated town in the state. Granby is part of the Berlin, New Hampshire, 18
So do you see what it's doing?
Statistical area.
It takes the it's really intelligent. It takes the data, takes pictures, syncs them together, and then presents them in such a way that it syncs up. It works really well. This is a great launching point. So if you want to learn something quickie, this is a great place to start. It's brand new. It's only like less than a month old. So I'm certain there's ways to make it better. But it generated this on the fly. It went out and got the pictures from different sources, and it synced it up and it read it to them. It works rather well. But anyway, here they are. Here's your video, Wolfram Alpha, Quickie, and fooplot. Yay, there we go. Okay, moving on. Go back here. Excellent. So we're going to take this now. Here is R6. Here is R6. You've looked at R6 before in terms of DIS, right? And VARD you did, I think?
Yeah.
So you've done disvard so far. How about this? Independently, so on your own, everybody, by yourself. Draw me a picture. Draw me a picture. Go for it. Domain, Ethan Goss. Two, 3, or -1. Agree or disagree, everybody?
Agree.
Agree. Intercepts. Jessica Brown.
0, 5, 0, 3, 5, 0, -2,
And what?
0, -2.
Anybody want to challenge any of that? I see 2 Y intercepts.
No, there shouldn't. Oh, maybe I said that. Incorporation.
It's 3, 0. 3, 0, 5, 0. And I see 2. It's -2, 0. Is that it? Okay. Symmetry. And we're going to go with Lawler.
Neither.
Agree? Anybody want to challenge?
Wait, for what?
Symmetry.
Oh,
Nope. Disvard. Vertical asymptote. Sophie. And X equals what? Challenge anybody? We agree?
Agree.
Agree. RD. Grace. 2, 3. 3 over 2. 3, -2. This? Who agrees with that? I'm sorry, which one's 0.5? -2.5, so -5 over 2?
Yeah.
Agree? Disvard, Hakatoa, HA, and let's go with Autumn. Agree or disagree? Agree? OA? None. And cross? Does this cross? Jonathan?
One cross.
Cross is at what?
At -4, 1.
At -4. Who agrees with that? At -4, 1. Who agrees with that? Where it crosses the horizontal asymptote. So you take this right here, and you set it equal to? You set it equal to what? 1. No factoring. Why are you factoring this? Look, so now what do we know? We know that this right here, for this to equal 1, what has to be true? Well, that's not going to work. This has to what in relation to the denominator? Yes, they have to equal each other. Stop factoring. What cancels? Whee! Right? And this becomes 0 equals 2x squared plus 2x plus what? No, minus what? Minus 24. What can you divide it? Well, factor out. What do you? 2 times x squared plus x minus 12. So that's equal to 2 times plus 4 minus, oh, you can't factor that. I'm sorry, I thought you were trying to factor the cubics. Sorry, my fault. So what does x equal? Negative 4 and 3. But what's the problem here? What's our domain? No 3. What happens at 3? There's a removal of discontinuity. So what are we looking at? Negative 4, comma. No, the horizontal asymptote is 1. So that is that. So now, do we have all the information we need to put together a picture? Yes.
Why 1?
Because we set it equal to 1. Meaning, we asked, where does this cross the line y equals 1? We have two equations. Where does 1, y equal 1, cross this equation? So you know the height has to be 1. Theoretically, if you plugged in, Pang, if you wanted to, you could take negative 4 and plug negative 4 into there. What should it come out to be? It should come out to be 1, but do you want to do that? No, I don't want to do that. You just hope it's right. It's comma 1. It's a point. Yes?
Y3 is not in domain, but it has 3 0 as intercept.
That's a mistake. So this right here is not an intercept. What is it? It can't have it because of what? It's a removable discontinuity. Does that make sense, everybody? So you're going to have 3 pieces of homework. It's broken down nicely. At least I think it is. So we can change this from verify to graph. So you're going to verify all the information that you came up with and graph R6 by hand. So make me a picture. I'd like you to play around with all 3 web tools of the day and come in with at least 2 cool facts about each. And I would like you to watch Graphing Rational Functions Part 6 and come up with at least 2 questions. Sound good? Okay.